we have a compiled makefile, and we have a ton of errors. And so I was fixing these errors this morning. I was kind of like, I just want to stream this because I found it to be a good plan. So anyway, we have a couple layers of abstraction, so to say. We have a GL shader class and a few other things. Anyway, so let's go into it. So we have this class that I made just today called the GL Shader Pipeline Debug State, and what that is it's kind of going to be our logger for our OpenGL error. And so we have a logger, or sorry, error set. We have a logger here, and we're creating it, and we might have an error or not, so we have a couple of states that can be outputted. So I need to test all of this, but before I do that, I have to finish it up. So anyway, so kind of want to wait for someone to come on, but that's alright. Oh, we got somebody on Twitch. Hey everybody. Alright, so we're working on this shader compiler. Anyway, so I decided that I wanted to have a pass state and a fail state, and the way I determine that is based on the fail or pass types, which are the success states and error states. And sorry, those are determined by this variant right here. So I'm using a variant, which is a C++ 17 feature, and so we have this state which can either be pass or fail, and I'll call this method, and it's basically a maybe. It's either the fail state or it's blank. We don't have a pass state because if the state passed, then we don't need a debug state. So we're gonna have this right here print the OpenGL error context stack. So we're gonna look at that in a moment here. So let's see. I'm thinking we should move this to a separate file because this file is getting rather large. It's about it's not too large, it's only 200 lines actually. So well, I'll open a separate buffer for two different views of the same file, and alright, so anyway, we're gonna have that open around here, the GL shader program kind of area, and then there's the logger pipeline area. We're gonna have this debug state be generated by this pipeline. It's already doing that here. So you see that it passes in the maybe into the GL get error. So anyway, so we're going to have this here do the binding steps. And so here, what I'd like to do is I'd like to have this as a tuple. And what this tuple is it's the name of the step in the bind process, or sorry, the pipeline. And after the name we have the function, which is the step that it needs to take. And so right here we're going to have our vertex attribute objects set up. And so if we, in the shader, we can see this layout is being defined here as location 0 and 1. And so we're going to enable those vertex attribute arrays. And that's the step 1. So we're going to have to set up objects in our terrain shader constructor, but first I want to figure out this pipeline. So to figure out the pipeline, basically we have this load GLSL file function, and we're calling it in the shader here, and so it will load the shader from this file, deduce the type of shader, and then place it into a shader queue, and it will load that buffer into the queue with the arguments that shader takes. So here, I said keep that there. Apologies. So here we see that when we scroll down, we have this GL shader class. And so what this class is it's basically our wrapper around the OpenGL functions. And in this wrapper, we're invoking the pipeline when we initialize the shader. And the reason for that is that this is what's called RAII, and we're doing immediate mode, where when we initialize the shader, we are invoking the pipeline for that shader. Anyway, so right here, we're attaching the shader to the program, but notice that the problem here with doing that is that when we place the buffer, it's going to run the pipeline, and that's a problem because we need the program ID to have that attached shader when or before the pipeline begins. So actually, we're definitely going to have to move the pipeline to a later step, the invocation of the pipeline, that is. So what we'll do here is we'll get rid of this parameter here, as well as the constructor. And what we'll do is we will move that to a different function. And it's kind of messy here, but because I'm stuffing it in a header, we're going to move this to a C++ file instead of a header file. But let's see, we're going to have a pipeline initialize kind of deal. So we are definitely probably just going to access the pipeline directly. I don't see a reason why not. So we actually don't need a function for that. But once we attach the shader, since this is a bind, and we're passing all these in, A bind is the same as a linkage, so what that means is that we want to take that to GPU memory. So once we attach the shader, we're definitely going to want to invoke the pipeline. And the way we do this is we take shader and we're going to take that shader and invoke its pipeline. So after we do that, it's going to go through each of these steps. And since this is a queue, it does it synchronously because that's important for the order of kind of that's really fun. Someone said, I liked your Vue tutorial, but I don't want to watch C++. Okay. Anyway, so we're invoking the shader after attaching it, and we're going to take that invocation and kind of look at the process behind what goes on there. So here we kind of have this make shader step pipeline, and notice when I invoke pipeline, I'm not actually providing a pipeline. So it's actually important that we set up a pipeline right here. So what I'll do, so let's put this on a new line. Actually, that looks pretty bad. Okay, that's whatever. I suppose this is fine. Anyway, so we're gonna call the pipeline constructor, and I think I want to. I was thinking of making a factory, but it's actually probably a better idea to invoke it here. Actually, or sorry, construct it here, but nah, I don't know. I don't think that's a good idea. So let's go ahead and make that factory function. So what this is going to do is it's going to return a it's going to be a template function, which means it's polymorphic. You have yours? No. Alright. Anyway, so we're going to take that template there of type name, and it's going to be shader shader type. And so we're going to take shader type, and we're going to make it so that it returns a shader step pipeline with shader type T. Oh, oops. What? So the reason I'm doing this is because there might be some special behavior based on the shader type, and so we might want to have some kind of config here, right? And so the way we're going to do that is when we construct, so I have it here. So when we construct the shader step pipeline, the constructor, we don't have a constructor, wait, yeah, we do. Which it just takes steps in the logger, but we might want to have different arguments for different shader step pipelines of different types. So I'm just making this a factory function so that if any of the construction parameters change, we can just change this method, if that makes sense. So so we're going to return a unique pointer to this, and what that means is that it's restricted to being used by a single context. Or if not, it needs to be moved to that context. Anyway, so we're returning a unique pointer, and the way we're going to do that, or invoke it, is we're going to just say make shader step pipeline of type GL vertex. Alright, and so that's going to create a shader pipeline and pass it to the constructor of our vertex shader. And so what this is called is we're doing a fold expression. So anyway, we're doing a fold expression so that when we construct each GL shader, we can basically pass an arbitrary number of arguments. But that was when we had the pipeline constructor in the the pipeline kind of code in the constructor of the GL shader. So what we're going to do is we're going to take the args that we passed here, and instead of doing that, we're going to pass it here into our shader pipeline. And what that is since the arguments pertain to the pipeline, and what the arguments are is this initializer list, which sets up a list of callbacks, or sorry, steps for the pipeline. So this is a pipeline steps, and it's an arbitrary amount of those steps. So right. So and actually it's also because there's a amount of there's both a multitude of shaders as well as a multitude of shader steps. Okay, and so actually that gets me thinking that this fold expression is miscalculated. What I mean by that is we look here to see that we are calling bind on the shader program of each buffer, but you know, this is taking an arbitrary number of arguments, and you don't really know what those arguments are. What we do know is that there's a buffer, but the buffer is inside those arguments, so we actually have to deduce the arguments from that initializer list. Anyway, so the index is fine, but when we get the buffer is going to be the first element of this initializer list, and it is, for some reason this is a template argument. I don't recall why, but I think the way I was thinking is that the arguments would be a template parameter, or sorry, the type. The thing is, we don't actually need that. We know what type it is. We just want multiple of them. And so I'll keep it the way it is, but just so that it's clear that that is the case. Anyway, I'll have to look at the documentation for the fold expressions. Anyway, so we're gonna bind the shaders. And so let me look for the fold expression. So I have this window open here. And so when we do fold expressions, okay, so it's definitely, we don't need that. It's just the syntax that's confusing me. So it looks like usually most, I guess when you're doing fold expressions, you want to apply it to the rest of them. In this case, I mean, we can get away with using a for loop rather than a fold. And then when the folding actually will take place when we pass the parameters to the shader. And so we actually don't need the fold, but we do need the range of multiple arguments. So when we bind this, what we're going to do is we're going to say that the arbitrary number of arguments is going to be a okay. We're gonna pass those. We might actually have to create a template for this constructor here. And so what we're gonna do is, sorry, not constructor, but this initializer list could be of, you know, an arbitrary amount. So the fold is going to go into the function called, let's call it setup shader pipeline steps. Oops. And we know that we're taking many shaders, so I'm gonna look up intuition for C++ is kind of rusty, so I have to look up some of the stuff. Yeah, C++, it's a language, but I'm using the C++ 17 version, so it's actually pretty nice. So it's periodic functions, that's the term for it. The thing about periodic functions is we don't need template, we just need this. Okay. Alright, so we can access that through VA Start. And the way we do that is we need to include the header, which is the C standard R. And this is the C version. You know, I'm thinking that maybe there's a type safer version. Or maybe not. I guess it doesn't really matter, but I like being specific about that. So. Oh, parameter packs, that's right. Oh, it is. So yeah, I'm not using C style stuff. So we still need that, but the difference is that okay. So yeah, screw that. So let's see, and that's gonna be. So in this case, it's always going to be shader programs, so I guess that's why I'm confused. So I guess I just have to specify the type instead of doing the template. So anyway, or sorry, it's an initializer list. And or is it? Actually, no, it's not. It's gonna be the what's this? The list of, let's see. That's right. Yeah. So here we have it so that this is used for the GL shader constructor, but this is used for the pipeline constructor. Now the thing about that is, since they're kind of unrelated, instead of having it in an initializer list, we're going to have it in a tuple. And so the tuple is going to be, it's going to have a standard string, and it's going to have the list of functions for the pipeline. But the thing about that is that it's an initializer list, so let's just go with an initializer list. And then how does the initializer list look like? It's like this. So see here we have this steps. So what that is, though, is we are going through the steps, and so it will be looping through that. And so what we'll do is we'll take that type right here and copy paste. I don't think this is right. I'll go into Y, but so I'm gonna, oh jeez. so okay, and the initializer list, we changed it so that it actually contains the name next to the function. And so what that, and I changed that this morning, but all this code, it's not right, it's not there right now. I have like 300 lines uncommitted at present. So anyway, we have a initializer list of a standard tuple. And we could actually consider making this a vector, but the reason why I'm not doing that is because I don't want to have that be constructed until it gets constructed, if that makes sense. So anyway, standard tuple of a standard string. Okay. And what this standard string is our buffer from load.gsl file. And there's an arbitrary amount of these being thrown into the construction. So anyway, what we got to do is we got to take that tuple, or sorry, the arbitrary list of these tuples, and we got to basically loop through them all. And okay, so we're gonna have index increase, and well, we need to fold the pipeline steps. So anyway, the reason I wanted this being a separate method is I just don't like having it be in the same method when it's completely unrelated. So anyway, we're setting up the shader pipeline steps, and we are going to pass arguments in here, but not those arguments. These arguments are these are the shaders. So these are uninitialized shaders that we need to set up the pipelines for, as well as the shader object itself. So like we said, we need to set up the shader object before setting up the pipelines. So anyway, we're gonna bind. What are we passing to bind? We need to pass the index as the second position, the buffer itself, which is going to be put there. Let's see. So I'm going to double check if I can do a fold or not. No, I can't. Wait, this is wrong. So we use a fold when we want to return, but in this case, a return of a unary operation applied to it. But in this case, it's not a unary operation. It's actually it's directly, so that'd be good for like 2 plus 2 plus 2, because you could map 2 or plus over each result, but that's not what we're going to do. So I'm going to just loop. So we're going to say shaders. Let's see this. Shaders. And then we're going to loop through the shaders the uninitialized shaders. Create a pipeline for the shader. Pipeline steps. Create pipeline steps for the shader. And so what we might do is, instead of making the shader pipeline here, we can actually do it up here in this method, which calls this method. So yeah, so we'll make the shader pipeline. Shader step pipeline. And we'll do so for the vertex shader. And these arguments here that are passed into bind shader are still going to be parsed, or sorry, put into GL shader, not pipeline. So get rid of this and move this to actually, I changed my mind. We're going to do that, but we're going to have pipeline set up here, and so we're going to hello. My YouTube channel is on the left, where it says channel feed. So you can check me there. I'm still gonna reply to the Twitch chat, but just if you. So I'm programming a game engine that uses OpenGL rather than like DirectX or something. And so I'm running a shader compiler in C++. So yeah, I'm running a shader compiler in C++. That's kind of so this is a lot of GPU stuff, but I need to set up a lot of stuff on the CPU. So anyway, we're looping through uninitialized shaders and binding each of them. So what we do is, since we need to loop through these uninitialized shaders, we're initializing them by binding them. And so we're going to take this tuple and we're gonna take the tuple. So So we're gonna say s get 0. I think it's okay, so we'll do this. We'll say standard tie. So we're going to say standard tie of the shader argument, and what this is it's an initializer list. Or sorry, it's the string and the initializer list, which is for the shader pipeline. So we're gonna say standard string buffer and the initialize auto pipeline args, and what we're going to do is I'm going to say buffer pipeline args equals standard tie. Or sorry, it's not standard tie. Oh yeah, that's wrong. It's untie. What? Let's see. I think it's just standard. You don't even need to. Oh, it's standard get. Oops. Standard get, and it's gonna be 0 on S. So we might want to pass those. What's this? So bind shader. That's the name of it. Okay. What did you need me to explain? I'm kind of like doing some pretty advanced stuff, so it's gonna be hard to explain it, but I'll do my best. Okay, well, let me finish this call right here, and then I'll try to kind of go through it. And by call, I mean this invocation of this bind shader function. This bind shader function is right here. This one, same one. I know it's confusing. I have 4 panes open, so it's kind of looking like I'm all over the place, but just kind of see right here, this little, that's what I'm moving, so, alright. Well, creating plugins is kind of different. Oh, hold on, let me get this right. Let's see. And I want to have this as a reference. So this is oh shit. Yeah, okay, I'm doing this wrong. I'm just gonna use an array. So yeah, it's pretty stressful. It's kind of like okay. Yeah, that was wrong. So okay, so that's an array, and this initializer list is array. Oh, it's actually a vector. Thing is, I want to know how many function steps there are, kind of at compile time. So I can do that. The way that I do that is I say, okay, it's a pointer function, and I'm gonna have num steps here, and then I'm gonna add a template argument called num steps. And so I'm gonna make it so that it's statically compiled to only take a certain number of steps. And the way that we can do this is we will take the size. So let's say find shaders. We have to get the size of the number of steps. And I think we can have dynamic template argument. Let's see. Yep. Okay. I'm dumb. Let's see. So this array here, we want it to be an array, but we don't really like the verbose syntax. So we're going to create some kind of function that will just intelligently, hopefully, determine what we need to do. Let's see. And so we need to, first of all, make it so that actually, let's see. Well, each shader can have a different number of steps is the problem. And so right here, actually it's well, I guess we can just use a vector here, but so vectors are dynamically sized and they can kind of be expanded, but arrays can't be. So the reason I want an array is because it's safer, more type safe. Anyway, so let's take this. So here we're gonna have how many steps? Let's say 3 steps. And so that's going to be the number of steps we invoke in here. So let's put this in a tuple. So we're actually probably going to make this a bit nicer, the formatting. So after we set up the VAOs, we're going to set up the setup MP, and then let's say we're gonna have set up textures, and yeah, and this is kind of our stage process. And the way we're doing it is we're kind of putting this into bind shaders. Now, this sort of gets me thinking with this static array stuff that we're better off probably using the initializer list like I thought. But that's very difficult to pull off, so we're going to probably just stick with the array. We could initialize the pipeline in the shader program right here. I guess I chose to do it in bind shaders because it's kind of easier to abstract that out or sort of keep it in there. But we'll just kind of go with the flow, see how it goes. So for some reason Emacs is screwing up my spacing. Oh, it's still screwed up. What's that? Oh well. So I guess I don't want this num steps here, because then the shader step pipeline of vertex shader is a different type than you know, this with 3 steps is a different type than 2 steps, and it's kind of weird, but I guess it doesn't really matter. And we'll fix that later on as time goes, but we'll kind of go with that, how that will turn out. So anyway, so we have our 3 steps here in our little stepper. I actually had kind of a stepper class here, but this is different. This is for time stepping. And you know, I also have my clock there, but this is kind of a different thing entirely. Where was I? Okay, and so we are going to set up the MVP here, and so what that means is we need all these GL ints and stuff to kind of be used in some way, and we want this to be in an object because it's easier to manage. So we're going to have some kind of MVP initializer or something. Or we're going to have it so that the grid is handled by the mesh renderable mesh class. And what this is it's a mesh. It's kind of complicated. So anyway, I might just call this mesh. So, don't forget, guys, I have a YouTube channel, and every subscriber makes me happy. So, let's check that out. Okay, guys, I'll post it in the Twitch chat just for you guys. Okay. Anyway, we're gonna move this kind of here. Before I just had this like single compile step, but the problem I was running into is I was like, well, where do I check for the OpenGL errors? You know, I can't do it every command. I have to do it at the end of the step. And so I made this little pipeline kind of protocol where I have this pipeline. It has a logger. It has an array of functions and steps and so on. There we go. Yeah, so this isn't going to compile for sure. There's just too much that I added that would just completely fail probably. But one thing I wanted to do was at least get some of it working. I know I'm missing a lot of headers, so up here, and so I have to import all those headers. And then it's kind of important that I document this as well. But this is kind of the way I want to do it. Where I have these steps and I kind of chain them together in a way to where it's trackable where things go wrong, and also to isolate scope so that there's not a lot being stored on the heap. So, yeah, alright, let's go ahead and, so we have textures here. When we set up textures, the mesh is probably going to do that for us, so I have to double check. So we have a mesh here. This is our implementation of our mesh. And we have init textures. And where do we assign the textures? We assign it in the constructor. So we can pass this directly to the constructor. The train shader program itself should have the shaders, or sorry, the textures attached to it. And so what I'll do is I ought to name them. So actually here we can see the model matrix and model are kind of important. So what we can do is we can actually make it so that when we set up the renderable mesh bind, so when we bind the vertex array to the vertex buffer object, we can actually set up the textures here too. So when we bind, so we have a bind textures function, and so that's going to be in the textures implementation. When we bind textures, it looks like we're hard coding to oh, here we go. Never mind. We're not hard coding this. Geoactive texture, and we are binding the texture's dimension using the texture's dimensions and its ID. And this goes back to the initial texture. Okay. And that binds the texture. So we want to bind these two textures in the setup textures step. So what are we doing? Well, we set up the mesh, but we didn't bind the mesh yet. And so there's a difference between setup buffers. So we can do setup mesh buffers and setup mesh textures. Those are two different steps. And so then what we can do is we can take this variable here, and since we don't need the textures directly because the mesh is the one that's interacting with those, we can put this in the constructor, and it will get the it will get the uniform location for us. I think this is. That should be geo. So, alright, so we have the get uniform location, and the thing is when we construct the texture, we want the texture to figure that out for itself. Alright, so let's see, where are we finding that out? Do we have a get uniform location for the texture class? That's what I want to answer. And it looks like we don't. Let's go to the texture header file, make sure that's not being set up there. And yes, we do. We have a uniform location, and it does so based on the name. So it looks like we are all good there. And sampler 2D, what is sampler 2D being passed here? So it looks like that initializes it. Oh, okay. So we have dimension, type ID, name. So the order we have here is wrong. Anyway, so let's see. And so that will get the uniform location, so we actually don't need to assign this. So that's model matrix, and this is the model. That doesn't sound right. In any case, we can get rid of this here. Thing is, the texture is being applied to the model matrix. It's not actually the model matrix itself, so I think that's an issue. So I think this belongs somewhere else. Let's see. Go back to the shaders. The shaders. Terrain, that's what it is. And this is really bad. think I remember. There we go. So this is a GLSL file. We have the normal matrix, the MVP, scale Z, tessellation factor, height map. Where's the texture? There is not the texture. So the tessellation map, plank, and then what about the front? About the frag shader, let's see. And it looks like yes, the textures are on the frag shader, so this setup mesh textures is going to begin in the next step after this one. Or sorry, the frag shader right here. So we'll have this here. Let's just have this step for now. And what's this? Okay. And then, oh, that's on. There we go. Okay. And, so I hope I'm not confusing too many people. This is pretty damn complicated. But it's so worth it. Anyway. Let's go ahead and see if we have this format correct. We do not. This, first off, this is an array. Let's write a vector. Oh, it's a tuple. So what does it make? Tuple. Man, cppreference.com is super slow today. I don't know what it is, but it's just loading like a dog. They need to like fix their stuff because something is really wrong. Okay. Okay, we're just gonna do this make tuple. Well, where's that? I think we'll have this two. So I'm making it very Lispy. I don't know if you guys used Lisp before, but notice I use kind of this thing where like I have them all stacked at the very end, like all the end parens and stuff. I like that stuff. Anyway, I think I don't have to use it's fine. Okay, we're gonna make a tuple here as well, and this is gonna be our tuple. And over here, and what? So, okay, next we ought to put this to a new line. What's this one here? Oh, that's right. Okay, I'm confusing myself because I realized I need the textures to be in the mesh, not the here. Okay, so oh Jesus. Okay, so blah blah blah. Sorry, this is the wrong file. Wait, okay. Would you guys want some music? I can play music. We can go with that if you want. I guess we could. I don't know though, because people don't really. What's that command you posted on Twitch? I don't really know what that is. Whatever can keep you concentrated. Okay, it does keep me concentrated. I was gonna explain plugins to you. But kind of. Okay, let's see. So, what do you got? Why do I have Maroon 5 here? I don't know. I don't know why. Let's see. I don't have that much music, to be honest, but I just ripped a copy of this album. Oh, too much weird stuff on this computer. Let's see. Yeah, it's not here. Here we go. I don't know why. I really don't know why I'm reflecting. I thought I deleted it. Is that too loud? I don't know. Sorry about that. Okay. I saw these guys live like 2 days ago. It was awesome. One of the best concerts ever. Okay. Oh yeah, this doesn't make any sense. This GL Gen textures. So, we don't. Oh, yeah, there we go. Let's see. Yeah, C++.com is way faster than CPP reference, even though people are like, oh, don't use C++.com. It's a bad resource. Yeah, right. You can go wait 10 seconds for CPP reference, I guess. Oh, okay, what's texture names? So basically, we can like create multiple textures at once in OpenGL. So this is why I'm doing GLDen textures. So when we create a texture, we're not actually creating the texture in an OpenGL sense. We're creating a container which will then contain a texture, and the texture doesn't have its own bind method. So basically, we're gonna have to bind it in the context of a collection of textures, because you wouldn't bind an individual texture. I mean, you could, but usually you want to allocate multiple textures, and so we have to allocate the textures on the GPU from the CPU, right? So we're gonna look here at Rendable Mesh, and when we initialize the texture, all it's doing is it's getting a uniform location. So after we initialize it, we're gonna want to create a name for it. But so that's done to bind texture. Sorry, that is done through. So the texture name isn't set, is what I'm trying to say. And so to set the texture name, oh, that's weird. I'm using texture name here, but I'm using texture ID, so I gotta make sure which one it is. So it looks like I'm using ID, so I wanna. Oh, name is a different thing. So let's go ahead and look at that. GL uniform 1F. I should know all this. I mean, like, I don't claim to know everything about this, but I know a lot. So. I mean, I didn't stream this for like a while because I was kind of unsure about it. I was kind of like, well, do I know enough? Oh, there you go. Wait. So when we set the uniform, we're binding the texture shortly afterward. So uniform location is the first argument, and then the value, what is it? It's gonna be. So I'm looking at these docs right here. Thanks, man. If you have a Google account, please subscribe to my YouTube channel. I have some more videos. I have a lot more videos. But anyway, so GeoFloat What did you upload? V1? Ah. So V1. So, I don't know what name is. I guess I kind of thought about that, and I might have tried to see what that was. So name appears to be model matrix in this case, but I don't think that's the value. That's clearly not the value of the uniform. So we did that wrongly. I think we need to make this a value. So anyway, we're gonna see about this. Let's see. So we're gonna look at GL active texture documentation. Let's see. And so this makes it active. Let's see. Okay, so I need to set the, it's not the name, it's gonna be the, active texture, so it looks like it's, what is it doing? This texture will, oh, okay. So that's okay. So it gets the uniform location from the name up here, if you notice. But we need to assign the value, I'm pretty sure. So anyway, that means we are going to use texture ID. Or sorry, yeah, texture ID. And we're going to assign the uniform location to texture ID. Oh, looks like it's a float. What am I doing? I don't know if we need this at all, to be quite honest. So I'm gonna scrap that real quick. Let's see. We don't need this here. Allocate texture names. Dang it. Oh. Ah.
Friday after dark.
Yeah, you got it wired in. Oh, okay. So no, we have to generate these textures and stuff. So the thing I'm kind of lost about is nice, man. I gotta figure out where the texture is supposed to get its ID from. Because I think the texture ID. Oh, looks like. Oh wow. Okay. Maybe again. So I renamed it just ID. So let me so when we init textures, that's just gonna get the uniform location. But we don't want to bind the textures right immediately. We want to do that in the renderable meshes bind. And so I noticed we don't have that. It's right here. So I pasted this. It's going to bind the textures first and then bind the vertex array. Binding textures needs to happen after the textures are allocated, and we can't. It's true that we can't initialize, or sorry, we can't allocate the textures without initializing them. So what I might do is actually, never mind. So we'll allocate the textures. So let's see, allocate textures. And we're gonna put our textures here. And so after we initialize them, we're gonna do allocate. So I'm gonna say create textures instead of init, because it's doing more than just initting them. Knitting. Okay. What kind of music is that you're suggesting? Okay, so we're gonna do we should I'll probably just do setup instead of create, because like it's actually not creating them, it's just setting them up. And it needs the shader pointer. So where does that get passed in? Well, okay, okay, so where are we setting up the textures? Nowhere. The way we have to do that is we have to make setting up the textures part of our kind of shader pipeline. So here we go. We have this shader pipeline. Look at that. We're going to set up the mesh textures down here. Okay. And look at this. We're going to set the mesh as part of our context. And we're going to do this. We're going to say, alright, well, right here we see it's in the constructor to pass the textures in. So here we have this. I'm going to go ahead and remove that here. Alright, I might play this. Okay, so I'm moving this to the constructor of the train shader program. So here we have the constructor here, right? Alright, looks like I kept mistaking the destructor for the constructor for some reason. Okay, so this is the textures, and basically in the constructor of the mesh, we need to kind of put those textures together, and so you might as well just make the mesh part of the constructor, so that way we don't have to do it here. Oops. And this grid class, I'm getting rid of that too, so I'm just gonna get rid of that. This is a dope song, by the way. Is it too loud? No, I don't think so. Okay, cool. Alright, so we decided we want to move the grid to, the mesh to our constructor here. And so how is it going to work? Where do we initialize the train shader program? Yeah, this is an awesome song. Alright, so I'm using a Kubuntu 1704. And this is Yakwig. It's like a, you know. And then I'm using Emacs. Yeah, so this is like pretty difficult stuff. I need to move a lot of this stuff. I have a height map algorithm. Look at this. Man, dude, I spent a lot of time on this. And so yeah, I have a height map algorithm, and I just need to get it working so that I can, or get the shader compiler working so that I can like apply the height map, and it'll be amazing. Anyway, so. Oh, okay. Rust. Yeah, I've played Rust. Thing is... Okay, I'm not gonna worry about it. And, so... Why is it doing that? So anyway, we're gonna have all these textures. Okay, and then we're gonna pass those textures in here, right? Thing is, like, these two textures in particular are pretty standard, so we're gonna. Okay. How's the microphone? I think maybe it's a bit loud, no? Okay, it's good. Awesome. I had a really bad microphone before, so if you look at my older kind of stuff, it's pretty bad. Damn, I have way too many freaking vertical panes. Damn. Okay, what is this? Oh, that's my home directory. Okay, oh, and you thought this was the end of that song, you'd be wrong. Okay, let's see. I don't think the model matrix is a texture. What am I doing? Let's see.
There won't be heartbreak in the room tonight.
Yeah, looks like.
Speak up. No names to remember.
Oh, it's nothing. Yeah, model matrix isn't supposed to be a texture, I don't think. Let's see. Yeah, it's not. Okay, alright, let's see, then the grass texture, that's pretty much it. And, we have a quad, so... So when you initialize the quad, the quad is like a GL rectangle. And so this is where we initialize the quad. It's when we create the landscape. Anyway, this is kind of pivoting from where I wanted to go, which was the shader compiler, working on that. So let's actually look here on bind shaders. Looks like our bind is incomplete. So we're binding the shader here, F-type is wrong. So, so we need to set up the pipeline in a separate step. So look here. This is not going to happen. We're not going to set up the pipeline in the shader itself. We are going to manage that for the shader. And the shader is going to be dumb. It's going to, basically, it's just going to look at the current kind of, sorry, it's going to, hold on, I have way too many windows. Okay, actually, I'm sorry, oh, too little. Oh, okay. Have fun. Okay, so I already had this. So I don't need this one then. But I do know that to be in that mode. Okay. What's this here? That's something else. This can go can go. This can go. Alright. Okay, okay, so we already said we're basically not gonna have, we're not gonna worry about the terrain shader too much until we actually get the compiler working, and so I'll have to look into textures as well. I'll have to do there. Okay. Wow, I have people watching on Twitch, but for some reason there's no one on YouTube. It's kind of been the opposite usually. Anyway. Alright. Alright, okay, so we're gonna continue looking at this shader set pipeline stuff. Anyway, F-type. Oh, that's right. Okay. So GLS load GLSL file is going to return that tuple. So the F-type is actually going to be less apparent than being there. So what I mean by that is it's gonna be a tuple, so it's gonna be a tuple of a string, as well as a what is F-type? F-type as well. So they're both strings, and so we're gonna go buffer we're gonna name this okay, and so that way we have I think we could just destructure it. We don't even have to do that. Let's see. Oh, there we go. It's like this. Right here. Okay. So we're gonna go auto. Okay, and so yeah, we're working on the shader compiler. Let's see, attaching the shader here. That's okay. We do that before invoking it. Pipeline. And so it's going to invoke the pipeline when we bind. Okay. We already determined bind is the step that puts the shader information onto the GPU. So right, so that should be correct. What about here? We're taking a variable number of arguments into the shader constructor. I don't know if that's what we want. Let's see. No, it's not here. What? Oh, it's here. What am I doing? There you go. Okay, so right here. Oh, okay, so when we construct the GL shader, we're using the buffer, right? And we also want to have a variable number of arguments, so we're going to do let's see. Okay, well, damn it, I forgot. Alright, we're gonna avoid having too many arguments with the constructor here. Okay. Ah. Okay, alright, we're gonna continue. Found it. Okay, so we have changed the queue so that should work now. Then we invoke the shader pipeline. So okay, this should be okay now. args here. Oh yeah, that's right. And plus we need the arguments for the pipeline. So we're gonna do this. We're gonna say pipeline args. And what's the first one? What's the buffer? It's gonna be for that. Come on, guys. Are you guys back? Where'd you guys go? Why'd you come back? I'm scared. Okay, blind shoot. There's the pipeline args. Okay, and what's going on? Okay, so pipeline args goes into bind shooter. Thing is, it's what is it? I'm just warning everybody. This song's like really like cute. You can't handle it. And, I don't know. Somebody left. Somebody's like, no thanks. Don't worry, I'm straight. Just kidding. I'm not kidding. Okay, let's see, where... Oh, that's right. It's in a mirror you need this. Oh wait, shit. I'm just gonna move the pipeline constructor here because this is a bit crazy. I just realized. Well, I mean, it's not too crazy. Oh no, it's fine. Gross. Save it. Save when this happens. Damn it.
Boy, you know I'm gonna treat you right.
Damn it.
Nicer than my heart. Heading faster than a snowball.
Ah, this is a conundrum. There we go. So we're gonna save the desktop file and restart it because Emacs, well Spacemacs particularly, sometimes it gets into a little fit about like everything. So okay, let's restart the development environment. It's gonna take like a few seconds. Whoa. Okay, let's see. There we go. So, oh no, you kidding me? What happened? What happened? It's the file, right? Oh, it's like a huge buffer, okay. Oh, here we go. It is. Oh, it's the wrong file. What? Damn it. Oh, what happened? Oh. Oh well. I'm gonna make a new desktop file. Damn it. Why? That was like the best desktop setup and everything. Christ. Oh, this is the wrong file again. Why is it doing this? Okay. I'm gonna have to make a new desktop file. That sucks. Okay. So. Thanks. This really sucks. Okay, anyway, we're just gonna move on from that file. We'll see how it goes without it. I'm just gonna set up my workspace yet again. Okay, then... So we're working on the shader compiler, right? Let's... Okay, and we were using the shader compiler and the terrain generator. Okay, and so we're gonna just make the pipeline like we're gonna make that happen somewhere else because this is ridiculous right here. We're gonna so we're gonna have this make shader pipeline like we called instead of having to do it over here. So we're going to have this, we're going to say pipeline, we're going to say vertex pipeline equals a make shader step pipeline of shader type. The thing is that we deduce the type of the shader. We deduce the type of the shader here from the file type, and so that's kind of like not that great, but I mean, it's the best we can do, but I think we can do a little more than that. So we're gonna have this just be an array that exists kind of separately, and so let's see, yeah, like this, and so that's how it initializes, and I guess we can create the pipeline type here. I'd like to do. I mean, I can still deduce that from the like file name, but I guess it's okay to be explicit over here. So instead of doing that, let's do vertex. No, I didn't. I don't think so. I still have to construct it here. So. We might make this a queue. And so, so we have this queue of loaded shaders. We are doing that in place. So yeah, all right. I think we can make this a queue as well. Okay.
Be lying next to anyone, but I'm still thinking of you. You're like the lighter to my cigarette. Can't set the flame without you. And if you want me to come over, baby, then that's what I'm gonna do. Just give me all your loving, don't slow down. I want you never hold back. Take me up to heaven. Oh, how I need just to be next to you. I need you here with me forever. I live you to love me. Love me, love me, love me, love me. Love me like it's right. I wanna hold you close like it's the very first time.
Oh damn. So we refactored it so that it takes a queue rather than an array, and so instead of taking an array, we're taking a tuple of arrays. Wait, no. We are taking a, what is this, shaders? Okay. So it is a tuple. It's a tuple with a string and a queue of tuple a string, any pointer or function. Oh no, I was gonna. see, we need the logger too. So yo. Oh, I lost you. Or did I? I don't know. What's up? So I'm working on this compiler. Yeah. What's up? Yeah, I've been doing this for the last like 3 hours. Oh, great. Yeah, I'm working on a pretty complicated piece of software. It's a game engine. And so I'm working on the shader compiler. I'm making like a shader pipeline, which is pretty complicated. Let's see. And we need the steps. Okay, I need to figure out where it's getting program name, shader name, and step name. I think I'm gonna have the shader pipeline logger have a well, it has a reference to a logger, and then the logger needs the shader information. So the shader has the pipeline. So I suppose the pipeline has to have a pointer back to the shader, I suppose, or yeah. Well, it's kind of weird that the pipeline has a pointer in the shader and back, but that doesn't really make sense. I guess when it invokes it, it can get the shader here. And we can do that. So when we invoke, we're going to logger and do this. And then step name is reference to the program name. And what? We gotta get the program name somehow. So we're gonna have that here. It's gonna go program ID. And that's there. There you go. It's gonna be oh, here we go. Why did it make shader step pipeline? I moved it here, I guess. Yeah, I guess that makes sense. I don't know why. I put it over here. I basically redo the entire thing. Oh, jeez. How embarrassing. Oh, wait. What? No, I think we're good. I think we didn't make it part of that class anyway. Whoops. That's fine. I guess, yeah, we can actually make that part of the class. So let's make that a method. So we're gonna have no shooters step pipeline. Okay, look at this, and make that part of the class, and when we initialize the logger, we gotta put it in the reference right here, so I'm gonna say, I think I'm just going to give it a reference to the program. I'm going to go auto, and then it's going to have a shared pointer to the program. And the reason why is I want to like be able to move it and stuff like in the share the program state. Do we have my program state? I guess not really. We just have the queue of shaders. That's a pretty big deal though. So we might want to not do that. I guess how do we want to do this? I'm just gonna go with the reference, good old C-style reference. I don't know, it sounds like a bad idea, but basically, we're gonna, when we initialize the program, or the shader step pipeline, it's gonna have a reference to the program. There we go. I'll be right back.
Someone else left the stream.
Patience, some people. Yeah. Make this.
natural state is enlightenment. Everything else you've ever been told about yourself is a lie.
Okay, we're going back to basics. Okay. Gotta stay hygienic, folks. Okay. I don't think we want to make the pipeline part of the GL shader. I mentioned that before, but I kind of went against that for some reason. So anyway, pipeline is going to be separate. I mean, it's still part of that shader. Well, it's a complicated relationship. No, it should be there. Okay. But the pipeline needs to be initialized by the program, basically. Otherwise, it's just blank. So, so this has to be typed to. So let's see. So what? I need to do this. See, we'll just have it there for now. We're gonna have to solve that. Anyway, so pipeline is definitely part of the program, or sorry, shader, and then we have to attach the pipeline steps, and this is. Here. So what we can do, I'm going to create a unique pointer for this pipeline, and so when we emplace the queue, so we have a loaded shaders queue, and we're not actually going to be iterating through that queue very often, if at all. It's really just there to emplace it somewhere, rather than just have it disappear in memory. So then, if you wanted to, you could delay the pipeline invoke. But since this is a bind stage, then you usually want to invoke the shader pipeline immediately, right after you bind it. For any reason, if I decide to change that, I can. But I can do this, and I can call this pipeline. And so it's going to give me a unique pointer to this function, or sorry, this pipeline, and I invoke that shader pipeline. And since I don't want that to disappear, what I'm going to do is I'm going to have to store it somewhere. So let's see. Where are we going to store the pipeline? We want to store it probably in the shader program. Actually, sorry, the shader stores the pipeline. But the interesting thing about the pipeline is it has a reference, back reference to the program. So let's see. Can we do that? I don't know. Let's see. I mean, the problem is I think the compiler might have some type of problem with auto used here, because I don't have it assigned to anything as a default value. So that probably won't work. So I'm gonna get rid of that, and then or maybe I'm gonna have to make sure about that. Okay, so I needed to find out where I need to store it. So cd plus auto class variable. I just need to find out. Yeah, you have to. Yeah, you can't. Okay, that's right. So the thing about pipeline is that it has a reference to the shader program because it needs it for the debug, but like we need to like put this somewhere so that GL shader kind of knows what pipeline it's doing. So maybe we can have the initializer deal with that. Because the thing is that the shader set pipeline relies on the shader type. So what's going on with shader type? Why do we need shader type again? Let's see. Oh, it's because of shader pipeline logger. Where is this using shader type? It seems like it's not. I'm thinking the reason I had it as shader type is because of the name. So I could output the shader type as an output in an error, but I think that's not a problem, so I don't need that. But I definitely do need the fail state. Thing about that, what is it? So the thing about that is that this has to be constructed as soon as we put it as a field in the class. So what does that mean? Well, we have to go so I think I still want to have shader type as a parameter here, but okay, so what I can do is actually oh no, let's wait. That's so we're doing like runtime type deduction here. So like I'm thinking we might need a virtual, you know. But the thing is we need this T here, and I can't combine static type deduction with, or sorry, compile time type deduction with runtime type deduction. So we have to like find some sort of middle ground, and that's difficult. So what we can do is actually we can like take the that's random. Okay, so what is shader type? So that can be GL shader or whatnot. So there's a difficulty, is that we need the types to back reference one another, and that's simply not possible. So we either need to decide whether we type or we store it on the GL shader, or there's some kind of manager that manages both the shader information and the pipeline, and I think I want to do that. So I'm going to do GL struct. I'm going to do struct GL shader, maybe processor, I think. And I guess what I can do is maybe I can have a unique pointer to GL shader, or any shader type, and then I can also have the pipeline too, so that should work. So let's call it shader, and let's call this pipeline, of course, and we'll have a unique pointer to both of those. And then maybe instead of having a queue of sorry, I'm kind of skipping around, but maybe instead of having a queue of shaders, we can have that shader processor. So that way we kind of keep the pipeline within the queue. And that way we know we're storing it somewhere in memory. Possibly. I think that's a good way to do it. I don't know. Oh, okay. Yeah. I had a few viewers earlier, I guess they're like, oh, that's cool, but, you know, like, no one's gonna watch some other dude code for 3.5 hours, I guess. It's kinda, it's whatever. Okay. Alright, so then maybe in the shader processor constructor we can construct the logger for the pipeline rather than having this make shader step pipeline type thing. Maybe we can have a make shader processor, or make GL shader processor, and it'll be a factory for that. Because we don't really want to have much functionality in the shader itself other than the GL type information. And the reason why is because we want to kind of decouple those functions from the rest of it. So let's see, we can have GL pipeline logger. What is this? Of what? Shader type? Okay, I think so. And it's going to need a reference to program, shader program. And we're just using a C-style reference because we just need to access some fields. And so But the thing is like I said, this would involve copy semantics, so we might just want to pass what we need in here and not have a reference to program. But there's a struggle. So we're gonna have this in the constructor, like we had before, I suppose. Or maybe we'll have a reference back to the processor. So we can say processor. So we can have so we can have a shared pointer to the GL shader. What do we call it? Yeah, so we have a shared pointer to the GL shader processor, and that way we can reference the program. And technically also this means we don't need to include the shader on the invoke, because we can just get the shader from the processor. So let's go ahead. So we're going to do processor shader name, and then also the program name. And you know, steps is coming here. And names, what is names? Names is the step names. However, we know that that's not needed because the step is a tuple. As we can see here, we have the name of the step and then the lambda. So what we can do is, since we know this is a tuple, C++ 17 or 14, I forget which version, allows us to do this. So we can do fn, and what's the name? We can do name. So this way we can just do tell the logger what the step name is, invoke fn, and check for GL error. And so this check error will return an optional GL error. And the logger is pretty complicated. I wrote it this morning. So anyway, shader processor has the pipeline, so we need to do this. So let's see. And okay, why is it doing that? There we go. And I'm missing tons of headers. I'm actually kind of just steamrolling this because I know it'll happen. It'll happen, I guess. And then, so that's going to have that. That's going to have a union pointer. And the interesting thing about this pipeline, like I said, is it's going to have, so the constructor is going to give it a back reference. So we do this. So the shader doesn't have a reference to the processor because it doesn't need one. The processor is what needs the shader. And so this is great. So we can have the constructor, as it's basically, okay. So we can have the constructor, it's not taking anything, but what it is doing is it's, I'm gonna move this out of the header file, obviously. It's gonna take it's gonna assign a pipeline, and it's also going to assign a shader. we need to do make unique, I think. And we're not making the shader here actually, so this is going to be required template parameter. So, and I think we can just make this auto, and then we put that there, and initialize that, and so we don't initialize the pipeline either. That's right, but we do need to give it that back reference. Now, I don't think we should put the back reference in the constructor. We're not necessarily going to need that in the constructor. I mean, I would like to, but it just doesn't sound like a good idea because then we'd have to move the construction of the pipeline to the shader processor, and I guess we could do that. Yeah, that's right, we wanted to do that. That's right. Okay. So really the only reason, once again, that we need that shared pointer is to access the program state. So, yeah, but once again, we run into that move semantics problem. So, what we might want to do is, get rid of the shader here, and put this back here. Now, well, the thing is that I feel like the shader should be tied to a specific pipeline. The pipeline should be tied to a shader. So I suppose it could be a unique pointer. Yeah, I don't see a big problem with that. The thing I do see a problem with is having move semantics on the shader processor. So I might, or sorry, copy semantics. So I might just disable copy on this class. I don't remember. I don't think there is a copy constructor by default, so that's actually probably not a huge worry. So, let's see. Looks like we need to make it private, so you can make it a class. And what we do, we have a so yeah, we want to disable that because we never ever want to have that happen. So we're not initializing the shader here, but we will initialize the pipeline unless we don't. No, well, we can just keep this make GL shader processor in this class and pass. Well, it does have a reference to program, right? Let's see. Oh, that's right. We need to make the program also uncopyable. So I'm just gonna get rid of this one. And so we'll get rid of that copy right there. We definitely need a reference to it though. So how we do that is we just have to, let's see, we got, well, really the logger is the only thing that needs access to the program, so I just need the program name and all that stuff. I guess we can just have that instead. I'd rather not have the program there as well. Maybe that's enough. Okay. Okay, let's see. Need to initialize a processor, and so that's gonna be kind of interesting. We decided to basically make it kind of have a queue of them and the processors rather than the shaders. I'm thinking that's probably why we should make the constructor happen for GL shader in the processor itself, but I guess that's not required. So the processor will happen here. We don't have copy, so let's not do that. And let's do unique. Let's just do auto pipeline. And actually, we should just do this in place like we said, and what we're going to do is we're going to take GL vertex shader, place that up there, and this is different than it was before. And so we are going to comment that and make the pipeline directly there. So it's going to be GL shader processor right there. Check that out. Okay, and then pipeline steps is a reference. Wait, is it? Well, it's a reference to a queue. Yeah, it's a reference to a queue. So we're going to place that. Alright. So that will make the pipeline. That's kind of difficult to read, though. It's definitely no fun at all reading that. So there we go, that's better. And since that's going to be the same for these, we're going to go ahead and just copy paste. And so that's going to be vertex, that's going to be fragment, and that's going to be a regular shader. The thing about the constructor for let's see. Never mind. Yeah, fragment, shader, shader. Okay. Set it. That is it. So replace the processor, shader processor. And since these are unique pointers, we can make a unique reference. And then, so we're going to kind of make this easier. That didn't work too well. Okay, and so this isn't pretty, but it definitely goes to show how efficient this really will be, because that's a pretty complicated kind of machine, if you will. It's kind of an effective abstraction, I think, because the shader processor has the unique references to both the shader itself and the shader pipeline. And it doesn't have a reference to program, but in the constructor of pipeline, we want to give them the program name so that when an error goes, we can have that. So shader step pipeline. So make shader step pipeline, and we need to take not only the pipeline steps, but also the program ID. So this is available because this is a program, shader program method. So we're gonna say this program, and this will be the name. Now, the thing about changing it up a bit is that since we're receiving the processor rather than the shader as before, down here, we also need to make sure that we, so name is here. What's shader ID? Shader ID, is that a thing? Yeah, it's okay. So instead of doing that, we will take processor, get the shader, and get the shader ID. And so processor has the pipeline and the shader pipeline. So anyway, so we have that. Processor's shader ID, and the program ID. And so we take we also have to make sure we copy the name here, all these, and okay, so now we need to check make shader program, make GL shader processor. That's wrong. We wanted it to make the pipeline. Make shader step pipeline. Because we decided that to be valid. So, and this one just calls the logger. And not only do we need the steps, but we also need the name of the program. And so we'll definitely copy that here. So in the initializer we have that, and then we also have what else? And the program name passed into it, and then so the pipeline has, oh okay, so it's it goes processor steps logger. Okay, and so the program name is needed for the logger, which is why it's in this function here. But the steps are here. And then we need, what's after steps? We need the logger, or wait, what? This is wrong. I don't know what I'm on about. Logger, program name. I was looking at the wrong constructor there. So the constructor for this doesn't exist. Great. Okay, and well, this exists, so let's just copy this and reuse it here. It's pretty much the same constructor. Shader pipeline logger, and the thing is though is we don't need the step name because the step name is set some other way, and so logger, so that goes here too. Goes here. And that is cool. Alright, we have those. We don't need the step name until later. We'll just initialize that to nothing, all that to nothing, and then an empty string. And check this out. And okay, pipeline logger, program name, and shader name. And the steps are part of a different, part of the pipeline constructor. So shader name. Well, actually, we need the processor too. And so, because the pipeline, as we recall, has the reference to the processor. or the shared pointer to that processor. Okay, I think I need to think about this a bit more and perhaps revisit it at a later date. Let's type a few things. Let's see. Shader pipeline invoke. Pipeline, where's pipeline? That's coming from the processor. And we already said the shader processor can't be copied, so shared pointer is kind of a problem. We do need that back reference though. Alright, that'll be all for this one. It's a 4-hour stream, so that's kind of long. We'll be back some other time, you know? Alright, thanks everybody.